Microservices architecture. The microservice architecture structures an application as a collection of small autonomous services, each implementing a specific business capability or function. These services are independently deployable, scalable, and communicate with each other using lightweight protocols, typically HTTP or messaging queues. This architecture style is particularly favored in environments that demand agility, scalability, and a high degree of flexibility. Now, some of the components of microservices architecture includes first individual services. Now, each service is a mini application with its own business logic and database capable of being deployed independently. Then we have the API gateway. Acts as a single entry point for all client requests, routing them to the appropriate microservice. Then we have the service registry, service discovery, or service registry, mechanisms for services to find and communicate with each other, often implemented using this service registry. Then we have the distributed messaging. Communication between services is handled asynchronously, typically through a message broker. And then we have the continuous delivery integration, which is CD or CI. Automation tools are crucial for testing, deploying, and scaling microservices independently. That's done through this. Now, if you look at through the entire picture, the clients, which are the web, mobile, and other platforms, are your client applications. Now, there is microservices, which consists of all these different things that we just spoke about, the components of microservices. The web, mobile, and other applications access these microservices directly through the API gateway, and API gateway routes them through the services which the user called, and that goes through the distributing messaging, which is the message broker. So this is the entire architecture for a microservices architecture. Now, what are the benefits and drawbacks? First is scalability. Each service can be scaled independently, allowing for efficient use of resources based on demand for specific function of an application. With flexibility, new business functionality can be quickly developed and deployed without affecting existing services. We have resilience. If one microservice fails, it does not bring down the entire system. We have technological diversity. Teams can choose different technologies and programming languages best suited for their services specific needs. Drawbacks: complexity. Managing many services and their interactions can become complex. Data consistency. Ensuring data consistency and integrity across services can be challenging due to each service managing its own database. Network latency. Increased communication between services over the network can introduce latency. Operational overhead requires robust operational infrastructure to monitor, log, and troubleshoot a distributed system. Let's look at an example. Here we have an e-commerce application built using microservices, which might include the following services. Now, if you look at in the services section, we have provided first one is the user service, which manages user registration, authentication, and profiles. We have product service, which handles product inventory, descriptions, and pricing. Then we have the order service, which manages the shopping cart, order processing, and status tracking. We have payment service, which handles payment processing, including credit card transaction and invoices. You can have other services like, for example, recommendation service, which generates personalized product recommendation based on user behavior. Now, each of these services would operate independently, have its own database, and communicate with others as needed using the RESTful APIs or messaging queues. Now, let's look at some real world analogy. Now, think of a restaurant franchise chain where each branch or service operates independently but adheres to common standards and interfaces. Each branch manages its inventory, orders, and sales, but they communicate and synchronize with the headquarters and other branches for broader business functions. Some of the popular use cases include a large enterprise applications. Large organizations use microservices to enhance agility and manage complex applications across diverse departments and teams. We have e commerce platforms, ideal for handling the varying loads and functionalities required by modern e commerce sites. Then we have the streaming services. Services like Netflix and Spotify use microservices to handle distinct functions like user subscriptions, content streaming, and user recommendation efficiently. Microservices architecture offers a robust methodology for developing large scale complex applications where each component is maintained by different teams and where flexibility and scalability are paramount. I hope you understood Microsoft services pretty well here. If you still have questions, please leave them in the comments.